Lecture 21, Multi-plate capacitors and variable capacitors. So this is a single capacitor having two plates and the capacitance is given by epsilon A by D. If we want to increase the capacitance, we can increase it by increasing the area. But in case we want high capacitance but with a smaller size and same area, we go for multi-plate capacitors. So this is the multi-plate capacitor. In this we are having four plates, that is plate 1, plate 2, plate 3 and plate 4. The plates are connected in such a way that it forms multiple parallel capacitors. So in this case, first and third plate are connected to negative terminal and second and fourth plate are connected to positive terminal. So in a way it is creating three capacitors, that is capacitor 1, capacitor 2 and capacitor 3. So we can say that for number of plates is equal to 4, there are total 3 capacitors in parallel. And the capacitance of these three parallel capacitors are directly added. So each is having the capacitance epsilon A by D. So total capacitance will become 3 times of epsilon A by D. So we can see that for 4 plates we get 3 times of the capacitance. So the general formula becomes, if n is the number of plates, then the total capacitance becomes n minus 1 into epsilon A by D. Now let's move on to variable capacitors. So these type of capacitors are used when we want to change the capacitance manually. So let's move on to construction of the variable capacitor. So it has two main parts. One is fixed plates and the second is rotating or moving plates. So by rotating the shaft, we can move these plates and insert these movable plates inside the fixed plates. So let's move on to the working principle. The fixed plates are connected to one of the terminals of the voltage source, suppose positive. Then the moving plates will be connected to another terminal, suppose negative. So initially when the moving plates are completely outside, then no part of the positive plate is facing the negative plate. Therefore, the net overlapping area is equal to 0. And therefore, the capacitance, which is epsilon A by D, is also equal to 0. But as we rotate this shaft, some part of moving plates comes in between the fixed plates. Therefore, the overlapping areas goes from suppose 0 to A dash. Now, the effective capacitance will be epsilon A dash divided by D, and since there are multiple parallel plates, the capacitance becomes n minus 1 into epsilon A by D, where n is the total number of plates. At last, when these moving plates are completely rotated and are completely inserted into fixed plates, then the overlapping area becomes maximum. Therefore, the capacitance also becomes maximum.